All right, well, Sunday afternoon, it's almost over. Thank you guys for coming. I think this might be the smallest crowd I've seen at any session this weekend. Although this morning was really light, I think you guys party too hard. I don't know how you all do that and then get up for sessions at 10 in the morning. That's just impossible. Anyways, so I'm Ben Stillman. I work for MariaDB Corporation. I am a principal consultant. I'm married. I have 2 kids. I like motorcycles. I am a data nerd. And I'm going to go ahead and put the contact info up now. So this is really boring stuff, admittedly. So if you feel like taking off, take a picture of this slide. Feel free to email me, contact me, do whatever you want. No harm, no foul if you leave. I'm not going to be offended. So where do we go? In my career, I see a lot of customer databases. And it's a pattern that I see over and over and over, that a developer or a systems administrator was tasked with installing MySQL or MariaDB and went as far as to make it work and then left it there. So nothing's been tuned, nothing's been configured, and nothing's been secured. There is a really cool utility that comes with every install, I think since like 4.0, called MySQL Secure Installation. This should be ran on every install of MySQL or MariaDB as soon as you do it. So, what does it do? Well, I don't know if you guys can see that well enough, but you just run the binary, MySQL_secure_installation. And it just goes through. The first thing it'll do is it'll ask you for your root password. If you haven't set one, like if this is a brand new install, there'll be no root password. So again, there's another reason why it's important to run this. So, set the root password. Pretty simple. By default, MySQL has anonymous users. So you want to drop those. And that's what one of the things this utility will do. Also by default, the root user can log in remotely from any host. So you want to strip that out. Root should only ever be logged into from the local machine. And then next it drops the test database. Part of the regression testing packages that come with every install of MySQL and MariaDB is this test database, and the anonymous users have full access to this test database. So imagine the conundrum if a developer is using the test database for, I don't know, production data that they're testing with, and they haven't done any of this, and you have anonymous users that can connect to the test database and view all this data. And then finally it reloads the privileges table, and then it cleans up and finishes and thanks you. And that's pretty much it, right? You've ran MySQL Secure Installation. You're pretty much done. Or are you? Mission accomplished. So what doesn't MySQL Secure Installation do? Well, everybody knows to look for a root user. It's kind of like SA and SQL Server. Everybody knows it's there. So you should change it. I always recommend changing the root user to something, in this example, purple elephants, JG, whatever. Default usernames are bad in every essence. So get rid of them. Symlinks. These were just the first 6 CVEs that I could find relating to symlinks. It seems like there's a new one every couple of years. Symlinks are dangerous. It allows MySQL to follow them. So imagine somebody gains access and is able to create a symlink to the MySQL.user table and load their own privileges table. You can imagine, and then next time MySQL restarts, it loads that privileges table, and they have full access to your box, and you're out. In MariaDB, you set have_symlink equals 0 to disable it. You'll want to check the syntax for different versions. In some places it was follow symlinks equals 0. Some of them is disable symlinks equals 1. So just check the syntax of the version of MySQL MariaDB you're on, but disable symlinks. Local infile. So as many of you have probably done, like load data in file and then load a CSV or a text document or something to load a bulk batch of data. Local infile is on by default, and it allows a user from their desktop or their laptop to run the load data. And you could imagine the problem of having one user keep trying to do, in this example, why can't I import 65 billion record CSV from my laptop? You'd be amazed. People try it. If they have access to it and they read it on the internet, well, okay, I can do that then. So disable that. You can imagine the denial of service on yourself, having a couple of people do that at the same time. Name resolve. Skip it. DNS breaks. DNS can be poisoned. DNS can be faked. So the best bet is to disable it completely. And where MySQL uses this is in mostly user privileges, in which we'll cover that shortly. But if you have a user Joe at abc.com, just use the IP address instead. And this one is kind of scary. We'll go into more depth with this later. But SQL mode equals no auto create user. Essentially, by default, if you issue a grant statement for a user, but don't specify a password, and the user doesn't exist, it will create the user without a password. So, what else can we do? Well, users and roles. First, we're going to cover users. Everybody knows the basic, create user, username at, IP address identified by, some awesome password. Always be as specific as possible with the host. If you can't say 10.1.1.14, you can do 10.1.1. %sign. So it'll allow anything on the 10.1.1 network. You can also limit it by subnets. You could even do 10% if you wanted to. Anything's better than at any host, which is what I see all the time. Always try to restrict your users to only be able to log in from the application servers or whatever. And always, always, always use passwords. And this is what I was talking about, a grant statement. Grant select on db.star to new user. This user doesn't exist. You just ran a grant without an identified by password. It's going to create that user and have a wide open, it'll have select access on everything, all tables in the DB database without a password. So that's why you want to set the SQL_mode equals no auto create user. So if you wanted to create a user by using a grant statement, just use identified by and your password. Next, and this one's kind of exclusive to MariaDB. MySQL 8.0 is introducing roles, but that's, I believe, not even a released candidate yet. MariaDB's had roles since 10.0. You can essentially create, instead of having to manage, say you have 500 DBAs, do you really want to manage 500 DBA accounts? And all the different individual privileges go along with it. Or do you just want to create a read-only role or a DBA role or any other role you could think of, assign the privileges to the role, and then grant that role to users. So, you've had a MySQL or MariaDB database up for a while. How do you know if you have any password or any users without passwords? It's actually pretty easy. You just look for an empty set in the password column of the MySQL.user table. And then you can go through and set a password for each of those users without a password. And it'll be really, really amazing how many users you have call and complain after you set passwords. Like, hey, why can't I log in now? Well, that's because you created an account without a password. Same deal. Find any users at any host. Just find them where the host equals %sign. And then you can rename the user. So in MySQL and MariaDB, a username is not just the Ben portion of this. It is the Ben at. So a user, Ben at localhost and Ben at 10.1.1.14 are identified as two completely separate users in MySQL. So you can assign different privileges based on where the user's logging in. So an example of that would be if you had a DBA that's logging in through a VPN versus locally at the office, you can give broader privileges for local access as opposed to logging in remotely over a VPN.
Can you assign like local roles? Can you assign like a bunch of the same users, different IPs to a role, and
I don't believe you can assign roles to roles. That would be kind of cool though, but the underlying structure, the role appears as almost as if a user, so it wouldn't work very well. But what you can do, and we'll get to in a minute, is mapping like Active Directory and LDAP groups. So the password hashing. Prior to, I think it was anything older than 5.0, used an older insecure password hash. The easiest way to find whether you have users with this old hashing or not is to simply find, do a select on the MySQL.user table. Here, let's see. This one shows better. Where the password is less than 41 characters, then you know it's using the old hash. And in order to set the password, you can change the password just using a set password command. Obviously, if you don't know what the password was, you're going to cause some problems. Ideally, this is an application user or something that's, know the password, and you can just set it to the same thing, but it'll use the new hashing algorithm. Once you've done that, you want to make sure that you have old underscore passwords equals 0. Any of the newer installations have this. So this is more for the older, older stuff that's hanging around, legacy stuff. So then we get to privileges. Grant all privileges on star.star.joe at any host. See that all the time. You not only want to restrict the host as much as possible, but you also want to restrict the privileges. You don't want hundreds of users in your database that, Lord knows are probably not being cleaned up and deleted when they get fired or quit or whatever. They have access to everything. Any kind of audit, you're going to fail an audit on this. What you'd like to do is narrow it down to the exact database, if possible. If they need access to all databases, they don't need all privileges. They don't need file. They don't need process. They don't need reload. They probably just need select, or select update, insert, delete, or sometimes process. But they don't need everything. So an example here then is grant select on db.star. So that gives them select access on every table inside db1. And you can grant insert update on db2.table.a. So you can actually go down to the table level privilege of what they're allowed to do. So they can select anything from db1 and insert update on anything, or on table A and db2. So that's a nasty query. But this this will list out all of the users and all of the global privileges that user may or may not have. And it'll be marked with a Y for yes or an N for no. So this is a good way to go through and just periodically audit what are your security privileges in your database. What users have global access to all tables. A user that was created 4 or 5 years ago, long before you added the new HR database, may have global privileges that you didn't even know about. And to show an individual user's grants, you can always do show grants for and then the user. And that'll give you the exact grant statements you need to recreate that user in another database or somewhere else. And that's always one of my favorite comics. It's so easy to steal passwords. So in this example, they're talking about you create a fake service that does something arbitrary that a whole lot of people would want to use, and they sign up for it with username and password, and then you reuse that password. But the reason for that is people share passwords, or not share, but people reuse passwords. So how do you keep that from happening within your database? Well, MariaDB has a couple of plugins. One of them is the simple password check. Very simple to install, and very easy to configure. What's the minimum length you want for your passwords? How many numeric digits do you want? Do you want it all the same case, or do you want to make it mixed case? And do you want to force special characters? So in this example then, if I try to set the password to ABC, it's going to fail because it's not 8 characters, it's not alphanumeric, it's not mixed case, and it doesn't have any special characters. But then if I use that nasty P4 $S word, that one will work. But that's a dictionary-based password. So that's not very secure. It's better than what we had before, but it's not very secure. So now you have cracklib password check plugin as well, which actually loads from a dictionary file, and you can specify your file. So now when we try to use that same P4$S word, it won't, because it's based on a dictionary word. So these are all just different. You can use these two password plugins in combo, and it'll help, and it doesn't eliminate it, but it helps reduce the likelihood that somebody's using, password as their password, or something really dumb. And a password like that would work. So then what else can we do for user authentication? Well, we have the Unix socket authentication plugin, which assumes that if the user has access to the operating system, then they have access to log into the database. So in this example, we've installed the plugin. Do who am I? Ben. Create a user. Won't work at localhost, identified via Unix socket. Try to log in with that user and it won't work, because I'm not won't work. I'm Ben. So then I create a user Ben at localhost identified via Unix socket. Now I log in with that username and it works. No passwords to manage. It's all handled through the Unix authentication. Additionally, you have the PAM plugin. Everybody knows what PAM is, probably. You can set up PAM to authenticate to all kinds of different things, and then create your user identified via PAM, and now I authenticate through PAM. Now this can be used for LDAP, Active Directory, all kinds of cool things. Like for instance, here's LDAP. With LDAP, we can even do group mappings. So we can say, LDAP group DBAs gets, you set up proxy users. Let's see if I have an example. Yeah, so DBA group, it gets the DBA proxy user. The accounting group gets the accounting proxy user. And then you create, and here's the actual PAM config. And you grant all privileges on star.star to DBA. DBAs get all privileges. And then you grant select only on db1.invoices to your accounting department. Then we create, and I hate to say this, an anonymous user. This is a catch-all because you don't actually have an account on the local machine or on the local database, because we're using proxy users. So what we do is we create this anonymous user, and then we grant it proxy. And that LDAP mapper is going to map the DBA group to the DBA user. So when the user logs in, they initially are logged in as anonymous, but then they're mapped to the DBA proxy user. So they have whatever privileges DBA has. The same thing with the user that logs in with as an accounting group. They're going to log in as that anonymous user and be mapped to the accounting proxy user. This way you don't even have to manage all of these users. So an example would be, who am I? Ben. Groups. I'm in the DBA group. I log in as user Ben, and it works fine. Same thing with Joe. Joe's in accounting. Log in with Joe. Now Joe is actually logged in as the accounting user. Now we create a user called Leet, and he's in the group Haxor, and try to log in with him, and he's not there because he's not in the DBA or accounting groups. So what else can you do with PAM? Well, you can use RSA Secure ID, two-factor authentication, have PAM authenticate to it, and now when your users log into the database, they have to log in with an RSA Secure key. Alternatively, Google Authenticator works as well. Two-factor authentication isn't perfect, but it's a lot better than nothing. Then we can also authenticate with Kerberos. It's currently in beta. I believe it's supposed to be marked GA in MariaDB 10.2. but it's fairly simple. Once you get the configuration, you install the plugin, which again, just like any other plugin, install SO name, the name of the plugin, already there in the plugins directory. In your configuration, you need to tell it where the key file is and what the principal name is. And then you just create the user. Then at whatever, identified via GSS API as Ben/MariaDB. This way you can kind of get your password management out of the database. You're already using some sort of central authentication. Why not just authenticate to it? So next up, it would be connection encryption. I would say it's probably about 5 to 10% of the customers that I see on a daily basis that are using SSL TLS connections for MySQL MariaDB. The biggest complaint I hear is about the overhead, performance overhead, when in reality there isn't much of one. To configure it is very simple. On the server side, 3 lines. On the client side, 2 lines. Then you restart your server, and you do show global variables like have SSL. If they all say yes, which they should, that means SSL is configured. And now, it's as simple as creating your users or modifying your users to require SSL, or use SSL if you don't want to require it. Now your connections will automatically use the SSL. You want to be very careful that your application is configured to use SSL for any SSL users. On the client side, it's easy. Like the actual MySQL or MariaDB client, you just add those 2 client lines to the configuration file. But your Java connectors, your PHP connectors, everything else needs to be configured to use SSL as well. Additionally, you can even use SSL for your replication. If you have master-slave replication set up, it's, you imagine you already have master-slave pair set up. You're not using SSL. It's as easy as granting usage, this is a little trick to add additional grants without changing anything, to require SSL. You stop your slave, then you run the change master to master_SSL equals 1 and restart your slave. Now your replication is going over SSL. Additionally, you can use SSL for Galera. It's a little bit more complex, but it's 1 config line. And you can use SSL for the Galera SSTs. And additionally, there's data encryption. There are so many different options for data encryption. New in MariaDB is data at rest encryption. These were patches supported or submitted by Google to us, Google and Perry. You create your key file, and then you add the configuration line, file key management file name, and which looks like that keys.txt example. You have key number 1, semicolon, the key. There are lots of different configuration options for it. The first thing you got to do is load the plugin. Then you say file key management, the path to the file, encryption algorithm, whether you're going to encrypt temp tables or not, temps and temp files, whether you're going to encrypt the binary log, etc., etc. Again, just more options for the encryption. Now, how do you use it? You create the table, has 2 columns, ID and value. And you just say encrypted yes, encryption key ID equals, and that matches that key file. So there was 1 key, you say use key number 1. If you want to encrypt an existing table, it's just an alter table statement. So some words of caution of using at-rest encryption. The slow query log is not encrypted. So if you have very sensitive data in your queries and it's slow and it's logged in slow query log, that's in clear text. Same thing with the general query log and the error log. The error log is especially scary because you could have full stack trace dumps dumped to the error log with all kinds of information. Galera's, if you use Galera synchronous replication, the Galera cache is not encrypted as well. Audit plugins not encrypted, et cetera, et cetera, et cetera. So it's not a catch-all. And, of course, only the data at rest is encrypted. So if you have that the server's up, the server's running, which hopefully your database server is 99.59's up, SQL injection, any kind of access to the database, this does not protect you from that. The data is unencrypted. Then additionally, there's the Aperry gateway. It's essentially a proxy that you would route all of your data, all of your insert, updates, deletes, and selects through, and it encrypts and decrypts data on the fly. This is a commercial product. But they helped embed the native encryption into MariaDB. Then there's DES encrypt and decrypt functions, where you can actually encrypt the data as you're inserting it. This only works if SSL TLS is enabled. So here's an example of a key file with 5 different keys. You can have up to 10 keys in this file. Unfortunately, as of right now, there's no native key rotation, but you could, if you wanted to, write your own in the background process to open data that has already been there and re-encrypt with a new key. And here's how to do the encryption of the data based on the key file instead of actually using a password phrase or string to do the encryption. Now, generally, your best bet is to encrypt the data in the application. You send it encrypted over the wire, you store it encrypted in the database. The database has only the encrypted data. If your database is compromised, it doesn't have the keys, it doesn't have a way of decrypting the data. So your data's fine. The downside, of course, would be you can't run search queries very easily. Well, you can't do select star where column is like, because there's no way of saying this encryption key looks like this encryption key. That's obviously not going to work. And then lastly, we have the MariaDB Audit plugin. Again, simple to install. Configuring it, you can set it to automatically purge, you can set it to rotate, you can set it to log to syslog, you can set it so that a user cannot disable it. The only way to disable it would be to restart MySQL with a different config variable. That server, server underscore audit equals force plus permanent. If that's there, it cannot be disabled dynamically. You would have to shut down MariaDB, remove that line, and then start it back up in order to disable the audit plugin. You can specify what users to audit or what users to exclude. So for instance, if you want to exclude everything, if you wanted to log everything but root, you could just say exclude root. And that's an example of what it would look like, logging everything. That's logging the connect, it's logging a disconnect, it's logging a write, it's telling where it happened, who did it, from where. You can log regular queries. You can, pretty much anything. You can log it all. Or you can say only log selects, or only log DML, or only log DDL. It's completely configurable. You can have it. Set it up whichever way you want. This was originally designed for PCI and HIPAA compliance, because the general query log is not very great for auditing. That's all it tells you is the query and the user. Whereas this will give you at least a little bit more information, and it's open source. You can actually download the plugin and install it on MySQL. If you don't want to run MariaDB, it'll run on MySQL as well. And that's it. That went a lot faster than I thought it would. Any questions?
Most like patches are that by default TLS 1.0
I'd have to double check, but I think we're only doing 1.1 right now. I think they've blocked everything else out, but I'd have to double check. Yeah, I'm genuinely not sure. I'd have to check. Yeah, I genuinely don't know. Sorry. I don't know what you mean by IP queries.
It's like IP where if you do your query, you can then look for /24, and you do that on dot star rather than an app. Or give it like an IP address. This IP address is in this /4, so it might return.
I don't think I've ever been asked that question before. Right. I know there are a couple of functions around IP addresses. It's like inet_aton, but I'm not entirely sure what all you could do with that or not. But if you shoot me an email, I will gladly find out. Yeah. Yeah, shoot me an email. I'll find out for you.
Wildcard and you're saying if use a permission flexor database, can you select wildcard from the database?
Say, I think you used to be able to, but you can't anymore. But you can do, because you want to do something like if your databases are all named DB and then a letter, you'd want to do like DB %, dot star. I don't believe that works. Generally, that's not something you'd want to do. But one cool thing you could do if you wanted to set up something like that, so say you have everything of DB and then a letter. You could use replication filtering to replicate to a slave server, replicating only the databases that match DB star or DB %, to another slave server and then grant access to all the databases on that server. Good. I'm always a huge fan of encrypting it on the application side, just for the fact that you're not storing the data and the keys in the database. Or using like the DES. I wouldn't do that either. The downside to that is your application's open to the world, I assume. It's a web server. Yeah, so now your database is on a server that's open to the world. So generally, you'd want to do a private IP. You'd want to, your web-facing application server, and then on your database server, have that on a private network connected to a different IP. I wouldn't recommend having your database on a server that's open to the world, especially with PII. But as far as what to do with PII, obviously the encryption at rest is only going to be good for if somebody shuts down your server and steals your hard drive. But depending upon what policies you have to abide by, like I don't know, HIPAA data or PCI data or some of the European regulations are now saying you have to encrypt even like email addresses. Usually it's sufficient to use data at rest encryption for a lot of those. For like email address or name or anything like that, I don't know how sensitive of data you're storing. But I'd look at probably the DES encrypt and decrypt functions and being able to encrypt the data actually in the column, as long as you don't need to do some sort of searching for that data. As long as you can match it, and if I want to return all the records where the email address is this, that way you can encrypt this and then find it in the database, or decrypt it. There you go. TrueCrypt. I haven't used that one. It's a more application side.